Evaluate the definite integral from 0 to pi over 4 of tangent cube theta over cosine squared theta d theta. With any trigonometric function, we first need to rewrite it in terms of sine and cosine to simplify this. This is now the integral from 0 to pi over 4, where tangent by definition is sine over cosine. So tangent cubed theta is now sine of theta cubed over cosine of theta cubed. And we still have cosine squared in the denominator and d theta. This is the integral from 0 to pi over 4 of sine cubed theta over cosine to the 5th power theta d theta. The goal is to use substitution to rewrite this in terms of either cosine or sine only. And so observe that in the numerator, with sine cubed theta, we can rewrite this as sine of theta times sine squared theta. But sine squared theta, with the trigonometric identity, sine squared theta is 1 minus cosine squared theta. And we rewrite this as the integral from 0 to pi over 4 of sine of theta 1 minus cosine squared of theta over cosine to the 5th power of theta d theta. And we let u be cosine of theta only, then du is negative sine theta d theta, and that's what we want. We have sine of theta d theta in the integrand. We then perform the substitution. If theta equals 0, then cosine of 0 is 1. And so instead of the lower limit of integration being 0, when we perform the change of the variable, the lower limit of integration is now cosine of 0, which is 1. For the upper limit of integration, when theta equals pi over 4, u of pi over 4 is now cosine of pi over 4, but cosine of pi over 4 is root 2 over 2. We do this because we don't want to obtain the antiderivative and rewrite it in terms of theta again. We simply evaluate the definite integrals indirectly. With u be cosine of theta, the denominator is now u to the 5th power. Cosine to the 5th is now u to the 5th. Sine of theta d theta is now being replaced with minus du, because du is negative sine theta d theta, and so sine of theta d theta is negative du, where the negative is negative 1, so we can put it in the front of the integral. After we substitute sine theta d theta, we end up with 1 minus cosine squared theta, but cosine of theta is u, so the numerator is 1 minus u squared. Before we evaluate the integral, we would need to simplify this first. The lower limit of integration is 1, the upper limit of integration is root 2 over 2 with the negative in front of the integral sign. The integrand can be rewritten as 1 over u to the 5th minus u squared over u to the 5th du. And this is not quite in the power form, not yet. This is the negative of the integral from 1 to root 2 over 2 of u to the negative 5 minus u to the negative 3, because 2 minus 5 is negative 3 du. And we can now use the power rule. The antiderivative of u to the negative 5 is u to the negative 4, where we add 1 to the power, and then we take the reciprocal of the new power, which is negative 1 over 4, minus the antiderivative of u to the negative 3 is u to the negative 2, where we add 1 to the power, and we take the reciprocal of negative 2, which is negative 1 over 2. and we evaluate from 1 to root 2 over 2. If we don't want to write many negative signs, we can switch the lower and upper limit of integral. This is now positive 1 over 4 u to the negative 4. Negative over negative 1/2 is positive, but then because of the negative sign in the front, we have negative 1/2 u to the negative 2. We then plug in 1 and root 2 over 2. But before we plugged it in, we should not write the negative power. This is 1 over 4 u to the 4th in the denominator minus 1 over 2u squared. Plug in 1 and root 2 over 2. We have 1 over 4 root 2 over 2 to the 4th power minus 1 over 2 root 2 over 2 squared. And that is only when we plug in root 2 over 2. Minus, we then plug in 1 over 4 times 1 to the 4th minus 1 over 2 times 1 squared. To evaluate the square root of 2 over 2, we observe that the square root of 2 over 2 is the same as 1 over root 2. And 1 over root 2 to the 4th power is 1 over 2 squared, which is 1 over 4. 1 over root 2 squared is the same as 1 over 2. And so we have 1 over 4 times root 2 over 2 to the 4th is now 1 over 4 minus 1 over 2 times root 2 over 2 squared is now 1/2 minus 1 over 4 minus 1/2. Simplifying this, we have 1 over 1 minus 1 over 1 minus 1/4 minus 1/2 is negative 1 over 4. 1 minus 1 is 0. Negative of negative 1/4 is positive 1 over 4.